Okay, can I ask you a question? Have you guys ever had a day where things are going perfect and then all of a sudden, somewhere out of left field, it's like it's not perfect? It kind of is exactly what happened. I just completed page 7 for the 7th and 8th graders, and when I was adjusting with the light on the document camera, everything that I had like stopped working and it stopped deleting, or it stopped working and it deleted what I had created. So I'm just gonna roll with it. Um, I'll go over on this video. I'm gonna go over again. Actually, I don't really want to do that either because it's all the work is completed. I was gonna redo and go through it again, but it might make it confusing. So I'm just gonna continue with page 8, and I'll have to with page 8, I'll have to do what we needed to do on page 7 anyway. And we are going to, we're just going to try to roll with it. Gosh, God, I'm tired. I can't wait for the span of my life to be over because I'm very tired right now. And I need to catch up on sleep. But that's not going to happen until probably this weekend because I got to get, I'm going to be staying home with the girls today. So if the girls are here, I can't sleep. If I do, the house will be destroyed if I fall asleep. So here we go. I'm going to flip the camera around again so we can finish page 8, and then I will make a video with the entire packet completed. Here we go. I just realized that I forgot to throw away my breakfast plate, and you guys just got a glimpse on. I used a paper plate to warm up some frozen pizza, and that's not warm up frozen pizza. It's pizza that was cooked, and I warmed it up. We had it last night for supper, and I had it for breakfast. But here we go. So, as I discussed in the video that got deleted, a tolerance is, let's say that we need an object to fit inside another object. Like, I guess if I could think of my phone case. So a phone case, I was just looking at the weather. So a phone case is actually larger than the phone itself. The tolerance is the space between the phone case and the phone itself. So you can't have it. Physics, the way physics and science works is you wouldn't be able to have two objects that are the exact same size, in the exact same measurement. They wouldn't fit into each other. One has to be a little bit larger, one has to be a little bit smaller. An example that I talked about when I was doing the last video that got deleted is this door back here. So like, let's talk about the door right here. That door. This door, I believe, is I'm just going off of what I think it is. I think it's a 32-inch door. If you were to measure the door itself and not the opening, you would find out that the door frame, so the part that the door closes into, is actually the size that doors are sold at. So if this is a 32-inch door, the distance from this edge of the frame to that edge of the frame is going to be 32 inches. The door itself will not be 32 inches. The door itself will be like 31 and 3/4. So that's what a tolerance is. A tolerance is the difference between. My kitty just joined the party. That's Twyla. So a tolerance is the difference between the smaller object and the larger object that the smaller object fits inside. So when you guys are creating parts, specifically in 8th grade, our final point value that you will get after you create some of your projects will be based off of the measurement that it's supposed to be and the measurement that it actually is. Sometimes when we create something, it might be a little bit bigger or a little bit smaller than the size that we set out to make. And in industry and in the manufacturing world, if you a lot of times there's an acceptable tolerance. Like, this is what you're shooting for, but it would work at this size and it would also work at this size. So it's basically a range of sizes that a part could be accepted at. So when you're figuring out tolerances, or when you're figuring out how many points you might lose for a specific project, it's basically the actual size plus or minus what the specified size was, and the difference in between that. On page 8, we're going to talk about how we figure out the point value subtracted from what you were actually supposed to have, like how many points you would lose based off of that difference. That's basically how that is going to work. It's a little bit, I was thinking about this as I was waiting for my computer to reboot and to try to get the computer program that I used to record the videos to work. I was thinking about the amount of complexity that this is. So if you don't understand this, don't worry about it. If it's something that's stressing you out and causing you to have a ton of anxiety, don't worry about it. If you figure it out, great. If not, just try to follow along with the video and try to make it work. I'm gonna flip the document camera around and just try to complete this page, and we will. Whoops, my alarm's going off. This is what time I'm supposed to wake up. Good news is I've been awake since for 2 hours already, so we're good to go. So here we go. Let's flip it around and let's try to get this page finished because we're already at 7 minutes. So good thing there's only 2 questions on this page that we really need to work through. Well, there's 3 questions, but we'll see how she goes. So a point will be subtracted for every 1/8 of an inch off, plus or minus, so 1/8 of an inch above or 1/8 of an inch below the required project plans. So the given, the measurement given in the project was 34 1/2, and the actual finished dimension that the person ended up with was 34 3/16. So we basically got to figure out what's the distance or what's the difference in between these two sizes. In order to do that, we have to make our fractions line up or kind of match up by making our denominators the same. 2 is a 16 is a common denominator between these two fractions. And so we're going to change that to 34, and the bottom is going to be a 16. Oops, dyslexia. That's supposed to be written on the top. So the bottom is going to be a 16. The top should be an 8. The actual size, or the size that we finished out, 34 3/16. Okay. All you got to do from this, once you converted it to a common denominator, is just subtract. 8 minus 3 is 5/16. 34 minus 34 is 0. So you were 5/16 of an inch off from the actual size that you wanted to, the actual size of the project. You were 5/16 of an inch off. How do you figure out how many points you're going to be losing? Here's how you do that. In order to figure out how many eighths we missed it by, because 1/8 equals, essentially with this, 1 point equals 1/8, you're going to go like this. So if you're going to lose 1 point for every 1/8 of an inch off, we have to convert eighths to sixteenths. So 1 point for every 2/16. And so we have to figure out, you would basically lose 1.5 points based off of that. No, 2.5 points. Because in order to get to 5/16, there's 2.5 1/8, and 5/16. So the student should have lost. I took a shortcut because I'm very tired, but that's the answer to this one. It's 2.5, because if we broke this down, you'd have 2/16 and 2/16 equals 4/16, and then you'd have 1/16 left over. So 5/16 equals 2/16, 2/16, and 1/16. If you added all those together, here's a point, here's another point, and this is 0.5 points. That's what that is. That's how we got 2.5 points. I took a drastic shortcut on that because it's like you're driving down the road and you're like, oh, there's the exit. I'm going to get off. I took a shortcut with that. So the answer to this one is 2.5 points because that's what the answer is. That's how far off we were. Okay. 1 point will be subtracted for every 16th of an inch off from the measurement. So the first thing we have to do is we have to figure out the difference between it. I can do that in my head just by looking at it, but I'm gonna do the long version for those that are not as experienced with this or don't grasp it as quickly. So we're going to change 12/16 we're going to change 12 3/4 to we have to change it to eighths. So 12 3/4 equals 12 6/8. Okay. And we have our finished size was 12 7/8. So the difference between 12 7/8 and 12 6/8 is going to be 1/8 of an inch. How many 16ths are in 1/8 of an inch? 1/8 equals 2/16. So we're going to be losing 2 points off of this project because it's 2/16. 1/16 equals 1 point. 2/16 is 2 points. That's basically that. Okay. So this one there's a lot of different things we could talk about. Why is it important to be accurate with measurement when following project plans? Simplest way to answer that is if your measurement isn't accurate, your parts won't fit together. That's the easiest way to say it, and the biggest thing to point out. There's a lot of different ways, there's a lot of different things, but the biggest thing is your parts won't fit together. If you are, like on the 7th grade projects, let's say you're measuring, you're putting your marks when you're laying out your project. Let's say you are just a little bit off. Let's say you're just a little bit off of when you're putting your marks down on the page. If you're a little bit off each time you do it, it's going to add up over time. Like the distance of where lines should be are going to be pretty different or pretty big if you make the same mistake several times over. So yeah, it's very important to measure accurately. Otherwise your projects won't turn out. But there you go. There's page 8. If you use what we did on page 8 to help with page 7, which I did this already, but it got deleted. Specifically that portion, it got deleted. I don't know if I have it in me to, I'm not sure if I have it in me to walk through that again, just because I'm running low on brain energy right now. So I'm going to end this video right here, and I will upload this. Then we will make an answer key video where you could just look at the video, pause it on each page as I flip through the packet, and just make sure you have the same things on here just to do a double check, and you should be good to go. Catch you on the flip side.